So thank you for joining us today. I hope you've been enjoying the wide range of talks from across the globe, looking at the cultural heritage in the coastal zone. And I would like to start by posing the question of how do marine surveys improve our understanding of the impacts of climate change to coastal heritage? I toyed with the title of my talk for a while, and I actually changed it a couple of times. And the main thing that I put into my title was the question mark at the end, because I feel that the point where we're at now is we're still very much trying to understand what is occurring, and Cherish as a project is really trying to feed in to that question and trying to do its part to remove that question mark of what are the impacts and what is occurring. And while I'm talking about marine surveys today, what I'm talking about isn't in isolation. And we heard from my colleague Sarah Davis earlier on about the long-term change that's occurring. And we'll be hearing from my colleague Louise Barker later on about the terrestrial side and what's happening along the coast itself. And that marine picture is tied into those two other elements. And it's one of the strengths of the CHERISH project is looking at these coastal areas, these coastal sites, and bringing the expertise of the different project partners, looking at the long-term trend, but also looking at holistically from both the land and the sea. And so for the next 15 minutes or so, I'll be showing some of the examples that CHERISH is doing to try and remove that question mark from the end of my title. You've probably seen this slide a few times over today. And so when I'm talking about the marine surveys, I'm talking obviously about the ocean side of things. It's the acoustic data acquisition by the vessels. It's the diving that we're doing on individual wrecks. But it also fits into that overall CHERISH toolkit. And critical to understanding the marine zone is also the aerial surveys that we do, the LiDAR, the UAV photogrammetry, and the satellite images that we take that knits the marine side into that terrestrial side. And in terms of feeding in to the CHERISH aims, the marine surveys are fundamental for targeting data gaps and for linking land and sea. And for our initiatives of the project, I guess a large part of what we're doing is linking that land to sea to create the seamless onshore, offshore maps, of which I have a couple of examples. In terms of the outcomes of CHERISH, there's the high resolution baseline data and the innovative data modeling and visualization and the way that we're looking at change, which I think that the key ways that CHERISH is trying to address the questions of what is occurring on our coastlines, to provide the evidence base for decision makers, and to try to identify the at-risk heritage sites. Where are we doing this work? Obviously on the coastlines of both Ireland and Wales, but we've targeted some key areas where there have been data gaps beforehand, where it had been shallow, so it had been very difficult to acquire data perhaps from previous surveys, and where there's significant underwater heritage, so some key shipwrecks along the coasts of both Ireland and Wales. And so the bottom left of that diagram, or of the image, so the diagram at the bottom left, in red is some of the areas we're looking at in Kerry, ranging from bays, individual bays, to individual shipwrecks, to offshore of Dunbeg. We're also looking at areas in Wexford, down at the south, around the Saltee Islands, and shipwrecks along that coastline. There's the City of London, which I have a few images for later on, and Dalkey Island. And over in Wales, then in both Cardigan and Carnarvon Bays, we've done previous surveys over the last 3 years. They're highlighted in red. And our final survey, we're looking to go over there later this year. And we hope we'll be successful and fill in a couple of the gaps which we've missed in previous surveys. So far, we've covered about more than 75 kilometers squared of area, getting new bathymetry data from those regions. And across the two countries, we surveyed 11 wrecks. And many of those have been repeat surveys. So we're beginning to build up a history of change occurring at these locations. And again, our colleagues in the Discovery Programme and in the Royal Commission are then targeting some of these sites to dive them to learn more about that information. So what kind of data have we been able to acquire? And I'll use some examples from the Welsh surveys. I think predominantly what we are doing and what we have done is create new maps of the bathymetry of that sea floor, of what it looks like. Because the shallow area is very difficult to survey in. It's where the waves break. It is extremely changeable from high tide to low tide. And it's very difficult to acquire high quality data in shallow water environments. And so the CHERISH project has been able to, because we're looking at coastal cultural sites, be able to justify going into those areas that have been previously unmapped. And it's a nice image on the bottom there of Sarn Badrick, a big reef where there are multiple shipwrecks on it. Previously, sort of like largely uncharted in terms of high resolution bathymetry. And our vessels over the last couple of years and completing now in 2021, we hope, has mapped certainly the ridge of that area and revealed what looks like a long glacial esker running along the length of it, which hadn't been expected and hadn't been mapped previously. Dotted along this ridge then are numerous shipwrecks. And so by understanding the bathymetry, that environment, we can perhaps understand more about the environment that these shipwrecks are now located and understand what could happen to them with predicted climate change. Alongside the bathymetry, other acoustic data is the backscatter, which can tell us some information about the type of sediments that's there on the sea surface. When you get a very strong reflection of sound back up, it's generally associated with hard substances such as rock or gravel, and that's you get high backscatter, which in the image, two images there, it's the darker grey to black color. And the lighter greys is then a sort of a low backscatter, which you tend to associate with sand or mud. So we're beginning to build up maybe a picture of differences between hard and soft substrate on the seabed. And we're using this data for 2021 survey to identify sites of seabed sampling, to actually put a grab sample down, select from the seabed, to then build up sediment maps of these areas of the time at which we surveyed them. So understanding the environment, particularly creating baseline data. Again, these are our newly mapped areas that we are going in to acquire this data to understand the processes that are occurring at it. We're also looking at shipwrecks. The two images on the right there, the top is the bronze bell, Carrara marble, situated on the sea floor with a number of anchors and cannon that then litter the sea floor around it. And the image beneath it is the diamond, both of them located on Sarn Patrick. And so have been able to map them. And if we do manage to repeat any of these surveys, or if there's historic data, we'll be able to look at the change that could have occurred between surveys. We're also using the bathymetry not just to identify new sites, but to try and link land and sea. And we have to understand that coastal sites aren't just impacted by one environment. They're not just impacted by the processes that occur in the marine realm or the processes that occur in the terrestrial. It's a combination of both. It's the high magnitude storm events that are occurring that are pushing the water up in storm surges that are increasing the wave energy, combined with your high rainfall events that are occurring on the terrestrial side that converge to impact coastal sites. And by creating these onshore, offshore maps, it allows us to use it as a base level, as a base framework on which to then, place our understanding of hydrodynamic processes, of other coastal processes which impact our coastal sites. And the key thing here then is establishing that baseline data to map what's going on currently, from which in the future we'll then be able to look at the change and really get to understand what is happening and what is occurring. The image at the top left there is offshore of Rossnagar, where we're able to use existing Maritime and Coast Guard Agency bathymetry with natural resource Wales LiDAR to create, again, a seamless map, but where there are gaps, to target those gaps with the CHERISH project. And the bit in colour is where we surveyed in 2019, and there's a little bit left that we hope to catch in 2021 to really create that seamless onshore-offshore map in that region. And again, the image at the bottom is of Ballinskellig Bay in County Kerry, where CHERISH has acquired about 12 kilometres of UAV data from the coastline. And we're now trying to infill that bay to get that bathymetry, to stitch it together, to better understand the processes that are occurring. Because what we're trying to do in CHERISH is we're trying to establish that baseline data, but also to look at a quantified change. And we've been able to do that onshore with our UAVs. These are one area in Rosslare, County Wexford, where we surveyed in 3 successive years. And we have able to monitor the change. And those panels at the bottom, the colored ones, red indicates erosion, blue indicates deposition. And what we are seeing first most is changes happening. What we are also seeing is that change is episodic, that different years see different rates or patterns of erosion. And we're seeing that onshore, we're seeing it in a coastal zone, but are we also seeing it offshore? And the answer is yes, that we're seeing very, very changeable conditions in the regions where we're able to survey offshore. And CHERISH is giving us that opportunity to go back to areas, to resurvey them, to try and see what's happening. And this is the City of London in County Wexford, which was surveyed in 3 separate years, 2015 with the Infomar programme, and again twice with CHERISH in 1820, and will return in 2021 to look at it again. And if we look at change, the image in the top left, again, color-coded where blue is deposition, red is erosion. The first image that we're going to see is the difference between 2015 and 2018, where over a 3-year period, material has moved into the system. But between 2018 and 2020, a lot of red, a lot of erosion that has then occurred in that 2 final years. So that image at the middle then looks at the overall change. That is medium-term erosion in and around the wreck. But if we get their intervals, highly changeable and highly dynamic. What CHERISH has then done is we've commissioned environmental data from consultants looking at the long-term weather, where CHERISH has then fed in bathymetry data that it's acquired to better refine the models. And the image at the bottom is a rose diagram of the wind, showing that wind's coming from all directions, predominantly from the southwest. But if we look at just waves and wave height, the majority of it coming from the south and a little bit to the southwest. And so what we're perhaps beginning to be able to do is maybe tie in some of the processes that are occurring in the coasts to some of the current environmental conditions, which is the first step to understanding what maybe the impacts of climate change will be as we move forward. We can look at another wreck. This is the Manchester Merchant, surveyed in 2009 by the Infomar programme, repeated by the CHERISH Project in 2019. And that image beneath it, the color-coded, red is erosion, blue is deposition. So at the bow of the stern, or the stern of the ship on the southwest of the image, the bottom left, we're seeing erosion, and then we're seeing deposition up near the stern, up towards the top right. This wreck is located in Dingle Bay, has an opening out to the southwest. And if we look at that environmental data that's occurring, again, we see that the waves coming predominantly from that southwest area, but much higher, much greater and bigger waves than what was at the City of London. Much in excess of 1.75 meters coming in. So different environmental conditions and maybe a different pattern of change happening here. Maybe we're seeing erosion focus at that exposed southwestern edge and deposition up in that southeast. But that could change as we resurvey the vessel over the lifetime of the CHERISH project. We're also looking at comparing, combining some of our different techniques, the marine stuff that we've been looking at. The image on the left is of Dublin Bay. We have a white ribbon that exists in the middle of Dublin Bay, in between the seafloor bathymetry of the Infomar programme and existing LiDAR data. And we're hoping to survey this year in May time, hopefully by the end of May, got LiDAR data to fill in that area to again create a seamless map over a large area. And the images of the right is of satellite images looking at what is there and perhaps comparing that to our bathymetry from the vessels. And what we're really trying to do is then take our marine surveys, the data we're acquiring, and integrate them with the other components of the CHERISH project, linking in the archaeological excavations, the environmental excavations with what's happening offshore and the environmental conditions that are happening offshore and impacting the site. And so to sum up and to finish, I think that the marine aspect of this project is helping us to improve our understanding of the impact of climate change. It's establishing baseline data, it's monitoring change now and in the future, and it's permitting new data to further refine our environmental models to understand what's happening currently, which is the first stage to understanding what will happen in the future with climate change. And with that, I'd like to thank you for your attention and hope you enjoy the rest of the conference.